When an LLM app is running, up is not enough. We also need to know whether it is answering well, using the right context, staying safe, and costing what we expect. That is the promise of observability. You've already seen how GenAI prototypes become production architectures, how RAG, APIs, orchestration, and integrations fit together, and how those systems are deployed, versioned, and released. Now the focus shifts to operating them intelligently. Observability gives teams visibility into latency, cost, token use, retrieval quality, safety issues, regressions, and real user outcomes. In standard software, observability often starts with a basic question. Is the service healthy? LM systems add harder questions. Was the answer useful? Was it grounded in the right sources? Did it stay safe, avoid hallucinations, and control token cost? Because outputs are probabilistic, failures can look normal in logs. Good LLM observability connects system signals with quality, retrieval, safety, and user feedback. A production LLM app still needs the fundamentals: CPU, memory, traffic, latency, throughput, and error rates. Those show whether the service is healthy, but they do not show whether the model is behaving well. For that, track tokens, prompt and completion length, model latency, provider errors, and cost per request. Then add quality signals like hallucinations, refusals, groundedness, toxicity, and user feedback. In RAG systems, retrieval latency, source relevance, recall, reranker scores, and citation coverage are just as important. To make an LLM system observable, each interaction needs a trace that follows it end to end. Start with identifiers: request ID, session ID, user or tenant, app version, prompt version, model version, and retrieval index version. Then record structured events as the request moves through validation, prompt construction, retrieval, re-ranking, the model call, tool use, post-processing, and feedback. Finally, attach measurements and judgments: latency, tokens, cost, retrieved documents, response length, user rating, safety classification, and evaluator scores. This gives teams evidence instead of guesses and helps diagnose issues, compare versions, and control spend. In a real LLM app, one user request can cross many boundaries before a response comes back. Distributed tracing gives that request a single thread to follow. Each major operation becomes a span: gateway handling, orchestration, retrieval, vector search, re-ranking, model call, tool execution, and response processing. This shows where time, errors, cost, or quality loss enter the path. OpenTelemetry helps traces, metrics, and logs share a common structure, with useful attributes like model name, prompt version, retrieval settings, token counts, latency, and failures. Think of a trace as the story of one user request. It starts with a root span, such as post chat, then branches into meaningful steps: input validation, retrieval, vector search, re-ranking, prompt assembly, model completion, tool calls, moderation, and response delivery. Each span records timing and attributes, such as model name, token counts, retrieval K, and latency. Trace context keeps those spans connected to logs and metrics across services. Add business labels too, such as tenant, experiment group, release version, or support ticket, so debugging connects to real operational impact. Tokens are the meter of an LLM system. They shape how much context you can use, how fast responses arrive, and what each interaction costs. Monitor prompt tokens, completion tokens, and total usage by user, session, feature, or tenant. Break latency into stages: retrieval, prompt building, time to first token, generation, and tool calls. Track cost with the same granularity by model, workflow, release, and prompt version. The goal is not just reporting. It is catching abnormal token growth, expensive prompts, throttling, and usage surges before they become customer pain or budget surprises. In a RAG system, a wrong answer often starts before the LLM generates anything. The query may be rewritten poorly, embedded with the wrong model, filtered too aggressively, or matched against a stale index. Observability should capture those decisions: document IDs, source systems, metadata filters, index version, top K, and re-ranker scores. Then connect retrieval signals to the final answer. If citations cover the response and sources are diverse, generation is easier to trust. If context is empty, irrelevant, or slow, you are debugging retrieval, not the model. LLM observability has to look beyond latency and uptime. The deeper question is whether the system is giving acceptable answers. Track quality signals like groundedness, relevance, completeness, hallucination risk, refusals, escalations, and task success. Also, watch for safety events, toxicity, sensitive data leakage, jailbreaks, prompt injection, and policy violations. These signals can come from rules, automated classifiers, evaluator models, and human review. Finally, segment everything. Averages hide problems. Break metrics down by model, prompt version, language, region, tenant, user group, and use case so you can see exactly where behavior changes. User feedback is one of the most practical observability signals because it shows whether the application actually helped. Capture explicit signals like ratings, comments, corrections, and escalation requests. Also, watch implicit signals. Retries, reformulated questions, abandoned sessions, copied answers, and completed tasks. The key is correlation. Every feedback event should connect to the trace, prompt version, model version, retrieve documents, and release. Then patterns become visible: confusing prompts, weak retrieval, unsafe answers, or missing context. Those patterns guide improvements and become high-value evaluation data for the next deployment cycle. LLM observability tooling usually works in 3 layers. Specialized LLM platforms give the richest view into prompts, traces, evaluations, user feedback, and model behavior. General observability platforms are stronger for application health, infrastructure metrics, logs, alerts, and enterprise operations. OpenTelemetry sits between them as the common language for traces, metrics, and logs, so LLM workflows can connect to the rest of your system. The right choice is rarely one tool. It depends on privacy needs, deployment model, integrations, cost tracking, evaluation depth, alerting, and access controls. Choose the stack that matches your operational questions. Observability is essential, but LLM telemetry can become a new data leak. Treat every prompt, retrieve document, user identifier, and model response as potentially sensitive. Before logging, minimize. Capture only what supports debugging, evaluation, compliance, or operations. As data flows into storage, redact, mask, hash, tokenize, and encrypt sensitive fields. Control access with strong permissions and tenant isolation. Use sampling to reduce exposure and cost without losing analytical value. Finally, define retention, audit trails, deletion workflows, and legal review, so telemetry remains useful only for as long as it should be. Observability creates value only when it changes behavior. Dashboards should be tailored. Executives need business health, product owners need user impact, engineers need model and retrieval detail, and SREs need reliability signals. Track availability, latency, cost, token usage, retrieval quality, feedback, safety events, and provider errors. Alerts should fire only when action is needed, such as SLO breaches, cost spikes, hallucination risk, moderation failures, or outages. Every alert needs a playbook. Likely causes, diagnostic queries, rollback choices, escalation paths, and first mitigations. That turns incidents into learning, not just noise. The key idea is simple. You cannot improve what you cannot observe. For LLM apps, observability means seeing prompts, responses, tokens, retrieval, quality, safety, cost, and feedback, not just servers. Tracing connects the full workflow, while privacy-aware telemetry keeps sensitive data protected. Next, these signals become the foundation for evaluation, reliability targets, and continuous improvement.